So, tangency task number 2. This is where we get a wee bit more complicated. Still using the same method where a pointy tangent is where a curve is meeting another line. Now, before I said it was a circle meeting a straight, and that's our pointy tangency there. Now, the other thing we can have, which is shown on these drawings here, is where this curve meets another curve. So we've got one curve here meeting a straight line, and this curve meeting a curve with a different radius. So that's two separate curves, and the pointy tangency point where they meet is here. You could work around your whole drawing and say, okay, where are my curves meeting a straight line at each point, approximately, to work it out. Now, we cannot use the straight lines method for working out where the centre of the arcs are. It'll work for ones where it meets two straight lines, or even one straight line. It will give us 1 point, because to find a centre, it's a bit like map work. You need to have a trig point. You need to have 2 points to find the third point every single time. So starting with this drawing here on the left hand side of the page, you're given both centres A and B, so you can draw the first circles and then the two circles over here relatively easily. You just set your compass at the size and draw a circle. Once you've got that, we've then got a complicated thing. How do we work out this top circle here? So we know at the point where this curve meets that circle, so it's about there on my egg-shaped circle, we know the distance here for this curve to the centre point is 75 millimetres. Now, the problem is I don't know exactly where that is on my drawing. I mean, it's messy as it is. So what we need to do is we need to pretend to move this curve to somewhere where we know it is, so that that curve would be passing through another point. Now, the easiest thing here is to say, right, okay, I want to move this curve. Instead of it being away over there, I want it so it would come through this point here. That point's the centre. We know where that is. Now, to do this, all we need to do is make that radius smaller. If it was a smaller circle, if it was a radius of 70 instead of 75, it would be 5 millimetres taken off the distance, so it would be a curve that's smaller. Now, we don't want it that, we want it all the way to here. So this is where a wee bit of maths comes in. You need to use the radius of the circle it's touching, 25, this one here, and the radius is the one you want. And all we need to do when it's like this is 75 minus 25. Which equals 50. Now that we've got that size 50, that's how big the radius would be if the curve was going through this centre point here. So with my compass, all I need to do is use the centre point, so this one here, and all I'm going to do is say, right, okay, what size is the centre? It's 50 millimetres, set my compass at 50, and I'm just going to draw a curve at 50, because I know the centre is somewhere on that line, but I don't know why, because I need 2 points of reference to find the centre point. So once I've done that, I'm going to jump to this other side of the circle, and we can say, well, I know at this point here, where this curve meets a smaller circle, it's 75 millimetres away from the centre, but I don't know where that is on, again, my egg-shaped circle here. It's going to be somewhere around about here. So I'm going to use this radius this time, and I'm going to do 75 minus 20, and that equals 55. And that would then mean I've worked out what would happen if this curve was smaller and it went through that centre point there. So it would, instead of being a radius of 75, the curve would be a radius of 55. So then, exactly the same as before, set my compass on this point here, and what I'm going to do is say, okay, set my compass 55 millimetres, draw a curve. Now when I draw a curve, I draw it going this way. And that then gives me where these two curves meet, that is my centre point for my top arc. So now I go back to set my compass at 75, and I'm going to say, right, okay, compass at 75, put the centre at this point here, and I'm just going to draw an arc that joins the two circles together. So that's how you do it for this method. The bottom is the exact same, the difference being that it's on this side and this side of the circle, so you're going to do 125 minus 25, so you're going to measure from the centre up 100 to get, go back to full screen, to get a centre mark up here, and then for this one it's going to be 125 minus 20, so it's going to be 105, so you'll get two arcs, and then that will give you this curve here. So that's the method you do when you've got a circle inside another circle. The way I remember it is if a circle inside a circle, you subtract the measurement. Now, for the next one, the catch is we've got some circles inside a circle. So like this circle here is inside this larger circle here. But we've got this wee cheeky circle out here on the outside. And the centre point is somewhere there. Now, we've got a straight line there. So go back to Tangency video number 1, and you can see, well, I measure perpendicular to that line, 15 millimetres, and I draw a line straight across. And that would give me where the centre line is somewhere on that. But I don't know where. And I don't know where it starts. So it's not as if I can just measure this distance here. So I've not got that. So what we do on this one is we've got a circle with a circle on the outside. So if we've got a circle, a curve, with another curve on the outside, so that's one circle here, you add. If the circles are inside each other, you subtract. So what I do on this one is this centre point here, 65 millimetres, plus the radius of 15, so 65 plus 15, and that's going to take us up to 80. And then from this centre point here, we just draw a curve at 80, and that will curve through here, and that gives you the centre point for a circle on the outside. Now the problem, the bit that always trips people up, is when you're drawing tangency circles, sometimes you have to work out one before you work out the other. So you need to say, right, okay, if I've not got this radius of 65, this one here, I can't work out that one. So I need to work out this one first. So on this one, I'd start off with this radius of 20 because I can work out that, draw a curve at 20. I'd then say, well, I know it meets this small curve somewhere over here. So then from that point, I can say, okay, R65 less 20 because it's the inside method, it's this one. So then I draw from this centre point a curve which is 45 millimetres along, and that will give me it there. Now the line does show you it's on the centre point, so you can say, oh, well, I need to do that. If not, then you'd say, well, I need to work out another bit on another drawing. Hope that's been really helpful, and hope you can do tangency now.